The definition of a derivative.
Okay.
And a derivative is the velocity of a certain point on a graph in an instantaneous value. So if you have a graph like this and you want to find the velocity at that point right there, you would use the derivative to find the slope of the tangent line right here. And a tangent line is a line that touches the graph at only one point, and the slope of this tangent line right here will give us the instantaneous velocity. And so how you would find that tangent line using the definition of a derivative is you would try and make delta x approach 0, so that's the limit as delta x approaches 0. And delta x is the change in x values, so you want the x values to approach each other and eventually reach 0, so you get a line that is perfectly tangent to the graph. So how you would do that is you would use the equation, the limit as delta x approaches 0 is f of x plus delta x minus f of x all over delta x. So example number 1. Say we have the problem x squared plus 4, and we were trying to find the derivative of that using the definition of a derivative. So you would use the formula right there, and it would be the limit as delta x approaches 0 of the function with a delta x in place of an x, x plus delta x in place of the x. So it would be the limit of x plus delta x squared, because you would replace every x value in the equation with an x plus delta x, plus 4 minus, you'd subtract the original equation from it, minus x squared plus 4, and that would be all over
delta x.
And so it would be the limit as delta x
approaches 0.
So so first you would FOIL x plus delta x squared. So x plus delta x squared, that FOILs into x squared plus 2x delta x plus delta x squared, and then plus 4. Whoops, there should have been parentheses around this right here. So then you distribute the negative sign through there, and you get minus x squared minus 4 all over
delta x.
And now you could cancel like terms on the top, so plus 4 minus 4, 4 minus 4 is 0, so you'd cancel those out. You have an x squared minus x squared minus x squared is 0, so you could cancel them out. And you're left with the limit as delta x approaches 0 of 2x delta x plus delta x squared all over delta x. You'd factor out a delta x from the top because all terms have a delta x in it. So then it'd be the limit as delta x approaches 0 of delta x times 2x plus delta x divided by delta x. Delta x divided by delta x, that cancels out. And you're left with the limit as delta x approaches 0 of 2x plus delta x. And now you could plug in 0 because delta x can approach 0 now. It's not in the denominator. So you plug in 0 for delta x and you're left with 2x plus 0, which is just 2x. So the derivative of the original equation, x squared plus 4, the derivative of that is 2x. So now I'm going to have me and you do an example problem together for you to understand it.
Okay.
So example 2, let's do 3x squared plus 5, and you want to find the derivative of that using the definition of a derivative, which is f of x plus delta x minus f of x over
delta x.
That's the limit as delta x approaches 0.
Okay.
Alright.
Me again?
So the first thing you're going to do is you're going to plug the 3x squared plus 5 into the original equation.
Okay, so
You're going to put an x plus delta x in for every x value for the original equation. So that would be 3, and then in parentheses x plus delta x squared plus 5.
where's the 5? Oh, I see where the 5 is.
And now you're going to subtract the original equation.
So 3x squared plus 5 again?
Yep, and use parentheses.
All over delta x.
Okay, and now again the
So
limit.
the limit as delta x approaches 0. Now I'm going to FOIL it.
Now you're going to FOIL out x plus delta x. So again, 3
So 3
times in parentheses x plus delta x squared is
x plus delta x squared is what?
x squared.
So it'd be x squared plus
2
delta x.
2x delta x.
2x delta x plus
Delta x times delta x, which is
delta x squared.
delta x squared.
Parentheses
Yep.
plus 5.
Yep, plus 5.
Take away 3x.
And now you're going to distribute the minus, so it would be minus 3x squared. And then you have to distribute it to the 5 as well, so it would be minus 5.
Over delta x.
Okay.
Okay, so limit of delta x as it approaches 0. So now I can start canceling things out. So I can cancel.
No. First, you have to distribute the 3 through all of those.
So it'd be 3x squared plus 6x delta x
Yep.
plus 3 delta x squared plus 5. Take away 3x squared, take away 5. All over delta x.
Now you could start canceling stuff
Now I can
out.
start canceling stuff. So I can cancel out the 5s. And I can cancel out these delta x.
Nope, you could cancel out the 3x squared
Oh yeah, the 3x squared.
and the minus 3x squared.
and then minus 3x squared.
So now you're just left with...
Now I'm left with limit delta x 0, 6x delta x plus 3 delta x squared over delta x. So
Now you could take out a delta x from the top, because there's a delta x in every single
so that would make
piece on the
that
top. The limit,
as delta x goes to 0. So it would be 5x.
it would be 6x, or delta x. Here. Erase that. Lift up.
Alright, so it would be 6
Delta x times, in parentheses, now open parentheses, 6x
plus 3.
No, you wouldn't use a parentheses there, because this is one continuous thing, so it'd be 6x plus 3 delta x.
Delta x
No, you took out a delta x, so it wouldn't be delta x squared over
nothing.
delta x.
Oh. Now I can cancel out the delta x.
Yeah.
And I'm left with the limit. Delta x goes to 0. I'm left with 6x plus 3 delta x. Now I can plug in the 0 for the delta x. So I'm left with 6x plus 0, which is 6x. So the derivative is 6x as it goes to 0. Am I right?
Yep.